Stars you should know for the spring sky with Dave Chapman on episode 326 of the Actual Astronomy Podcast. I'm Chris, and joining me is Shane. We are amateur astronomers who love looking up at the night sky, and this podcast is for anybody else who likes going out under the stars. So Dave 17 Chapman is a physicist who worked 31 years for the federal government. He is a fellow of the Royal Astronomical Society of Canada and a former editor of the RASC Observer's Handbook. He is a lifetime amateur astronomer, lives in Dartmouth, and he even has an asteroid named after him. This is Dave's third in a series by season on stars you should know. Welcome back to the show, Dave.
Well, thanks for having me back. I'm really delighted that this series idea has taken off. I knew the winter stars would be exciting, and every time I've done one since then, I've always thought, oh, is this going to be interesting enough? But whenever I finish the notes for the show, I always think, oh, this is going to be great. So this is going to be great. Thanks for having me back.
Yeah, we're looking forward to it. So, Dave, we've done the winter stars, we've done the northern stars you should know, and now this is going to be the spring stars you should know. So where would you like to go to get started?
Yes, spring stars, and you pointed out the other day that spring is almost over, so we've got to get this done. There's an interesting thing about the spring stars that I don't know if you've ever thought about, but people are not as familiar with the spring constellations, and do you know why?
Because usually it's raining in spring?
No. Well, we know that every night, if you look out every night at the same time and we look at the sky, we know that every night it sort of advances towards the west by a few minutes of time. But in spring, what happens is not only is the sky advancing towards the west every few minutes per night, but the days are getting longer and the sun is setting later. So you have to wait up later and later at night to see the stars. If you look at it when it gets dark, the spring constellations just whip by, they're going by really, really quickly. And they don't spend a lot of time in the evening sky. And the opposite happens in the autumn when the summer stars stick around forever. Like you can see the summer triangle way into October and November. Anyway, that's one reason why people might not know the spring stars and constellations as well.
Makes good sense.
Also, there's not as many bright stars, and we'll see that in what comes. So should we get going?
Yes.
Let's
so
do
how
it.
many stars in constellations are we doing today? Is it 12 stars?
I've kind of settled on a dozen. A dozen seems like a nice round number. And the first few are always, pretty notable stars. And then I always throw a few kind of interesting ones in at the end, which may not sort of jump out at the sky at you, but are still worth looking at. So we've got a dozen coming up. And I just want to remind people that we're going to be focusing mostly on the Greek and Roman names and meanings, although there will be a few references to First Nation terminology. The other thing, I'm going to be talking again about spectral classes, and I'll just go through those from blue through white, yellow to orange and red. The spectral classes are O, B, A, F, G, K, and M. And those were introduced by Annie Jump Cannon, I would say well over 100 years ago, I believe. And that's another homework assignment is maybe to read up on that story of how she did that and why they're named that, and so on. The colors and the spectral types of the stars are quite important for stellar evolution and just knowing how basically the universe works. So we've got 12, I would say, bright stars because they're all brighter than magnitude 6. So they're from magnitude 0 to magnitude 6. 9 of them are okay to find. The last 3 may be a little bit tricky in the city. But those first 9 are used for celestial navigation. Now there's 58 stars in the sky that are used for celestial navigation. And by that, I mean in the good old days when people had sextants and chronometers, and they would shoot the stars and consult tables of positions and work out their position on the Earth using astronomical means and observations. And you can get that to be fairly accurate. Nowadays, we use GPS satellites and all that kind of thing. So they're kind of running out of favor, but I think for historical context, it's nice to point these out.
I have a quick question, because you
Okay.
were somebody who worked as a researcher out at
Yes.
sea. Did you ever use a sextant? And if so, can you give us like a really 25-second rundown on how to use a sextant?
Well, I could. So basically, a sextant is an optical device. It's like a mini telescope. And what you do is you look at the horizon at the same time as you look at the star through the telescope, the tiny telescope. And there's a way that you can adjust the two images so the star looks like it's on the horizon. And then you read off the sextant what its altitude is. So it's a very precise instrument. So you're lining up the image of the star with the image of the horizon, and then you read off the altitude. And those numbers and the time, you do that for 2 or 3 stars, and then you go and do a bunch of calculations. And yes, I have done that. I've shot the stars with under the direction of a navigation officer. And in those days, he had an HP calculator, and he had a piece of software that you could put in it where you just punch in the numbers that you found, and it would turn the crank and it would pop out a position. And I did that once, and I was within a few nautical miles of where we actually were, according to the other navigation aids. So I've only ever done it once, but yeah, it's kind of fun. Yeah. Yeah. Well, there's a lot of history around this. A lot of astronomy back in those days had to do with finding where you were. And, this is why governments supported astronomy, and where there were things like Greenwich Observatory and time clocks and people measuring the transit times of different things. That all of this was all about, dominating the world by navies, and knowing where people were or where people are, and so on. But that's a bygone age now. The first 5 of these 9 are also Skywatcher and SynScan and Celestron alignment stars, which, as we discussed before, they're useful to know if you're actually using the star names to align your telescope. These days, there's ways of aligning your telescope without even knowing what you're looking at. And I could go on about that. But in some of the older versions of this software, it says, point your telescope at Caph. And you go, where the heck's Caph? So it's good to know the names of these stars.
So what constellation are we going to start in?
Well, we're going to start in Leo, right? Because Leo is like the quintessential spring constellation. It's pretty big. It's high up in the sky. It's got a bright star in it. So how do you find Leo? And that's really super easy. If you don't know how to find Leo, this is how you find Leo. First of all, you go back to the good old Big Dipper, which we use for finding a lot of things. And you take the pointer stars of the Big Dipper, and instead of going north to find Polaris, you go south. You go south with the pointer stars, and you eventually get to Leo, or pretty close to Regulus. And that's how you find Leo in the night sky in springtime. It's a pretty big constellation, and actually, when you do the stickman approximation of Leo, it actually pretty much looks like what it's supposed to be, which is the lion. Leo is the king of the beasts, the lion, and you can easily pick out its head and mane towards the west, and towards the east, its tail, and then if you get into some of the other, there you go, you've got the cartoons there. Yeah. And so Regulus is Alpha Leonis. It's the brightest star, or the main star. And it comes to the word Rex for king. And Regulus means little king, the little king. And this goes back to antiquity, the identification of this star with Leo. It marks supposedly the heart of the lion, okay, the lion's heart. So it's a magnitude 1.4. It's a variable double star. It is a blue-white B8 star. So that makes it pretty hot compared to the sun. So it is, again, a classic navigation star and used in sky alignment. It's closer to the ecliptic than the other 99 brightest stars. So that's kind of an interesting thing. And that means that it quite often gets occulted by the moon as the moon goes through its phases. And it also engages in close conjunctions with planets like Venus, Mercury, Mars, Jupiter, and Saturn. So you get these nice arrangements. Another homework assignment is I was fooling around with this the other day, and I noticed that the lunar occultations of Leo seem to take place in sort of periods of time that are separated by about 10 years. Like there'll be a long time where you don't get any, and then you'll have a whole bunch almost every month for a while, and then it goes quiet again. And that's because the moon's orbit is tilted relative to the ecliptic. So it's almost kind of like an eclipse. The node of the moon's orbit has to be close to Regulus for those occultations to take place. It has a binocular companion. So with binoculars, you could try for the binocular companion. It's a little challenging because the companion is only magnitude 8, but it's there. And certainly in a telescope, you can pick that out. Even if you throw a small telescope on Regulus, you'll see that 8th magnitude companion. So it's worth knowing, and it's worth looking at. It actually is a multiple star system, and one of those multiple stars is in fact a white dwarf. So it's a very interesting star system from the point of view of astrophysics. There's a lot to be learned about. There you go. I think that must be, I'm not sure if that's that's just a nearby star. I don't think that's the double, but anyhow, it's a very interesting star worth doing some research on if you're into that kind of thing. So now we're going to move over to the other end of Leo, as we say down east, the arse end, right? So that star, which is part of a little triangle. Of course, I was just saying before we started recording that take any 3 stars in the sky and it makes a triangle, right? But there's a pretty there's a pretty evident triangle there at the rear end of Leo, and the brightest star in that part of the world, the sky, is Denebola, which is Beta Leonis, and means the tail of the lion. Now, you see the word Denebola, and you think, where have I seen that before? Well, there's another star in the sky named Deneb, which is the tail of the swan, and it's just called Deneb. And that's because the word Deneb itself is derived from the Arabic word for tail. And this is a true homework assignment. There are 5 other stars in the sky named Deneb something. So there's different constellations, and you'll find Deneb named stars in 5 other places. That's your homework assignment.
Interesting. Are they all Northern Hemisphere, Dave?
That's a good question. Not necessarily, but they might be. They might be. I know one. Well, I'm not going to give it away, but
Okay.
But it could be that some of those are Southern. I didn't. I'll true confession here. In the interest of time, all I did was type Deneb into Sky Safari in the search button, and it came up with 5 things, and I just counted them. I didn't really go into. It was just like, okay, I got to move on here.
Yeah.
Believe it or not, it takes some time to put these notes together.
No, that's an interesting note, though. I'll definitely check that out.
Any one of these stars will lead you down a rabbit hole into a whole other realm of investigation, and so I find it takes a long time for me to get these notes done because I get interested in everything, and next thing you know, I'm spending 20 minutes on one star. So it is a magnitude 2.1 star, so it's a little dimmer than Regulus. It's a slightly variable star. There's a lot of variable stars in the sky, but some of them are so mildly variable that you would never notice it.
And for all of the listeners, Chris has Stellarium on the screen right now, kind of zooming in and out of what Dave's talking about.
Yeah, and I just noticed that the dwarf planet Ceres is not far from Denebola right now. So if you're inclined to be an observer, once you go look at Denebola, you won't have far to go to find Ceres. And Ceres is reasonably bright. I think it's around 8th magnitude at the moment. And I've been taking pictures of that as well with the robotic telescope. So it's a classic navigation star and a sky alignment star for both Celestron and Skywatcher. nothing much more to say about the nebula. I want to go on to Hydra. Hydra. Now, this is where kind of things get interesting. Hydra, you got it there? Hydra is the water snake. And those other constellations nearby, Crater and Corvus, are involved in a very interesting mythological story involving Hydra, the Crow, Corvus, and Crater. No time to go into it, but if you like that kind of thing, there's a whole story associated with Hydra. And so it's a mythical sea monster, and I think it was one of the labors of Hercules to kill it. And I believe it has multiple heads. And then when you cut them, they grow back. And so that made it a bit of a challenge to get rid of it. But it's the largest constellation in the sense of how long it is. It spans nearly 6 hours of right ascension. So it goes about a quarter of the way around the sky. But the stars are very dim. So it's not very well known because there's not very many bright stars in Hydra. And here's the thing. I've asked for the people that are viewing this, but you can also do this at home with your own software. If you go back to about 2000 or 3000 BC and look at where the equator lies, yes, everything moves around because of the precession of the equinoxes. And at that time, I mean, Hydra zigzags back and forth, but basically Hydra ran along the equator in the time of the pharaohs and those the Mesopotamians and that I think is significant that when these constellations were first being put together, they took this long water snake and they ran it along the equator. Of course, now because of the precession, it's no longer along the equator. But I just thought that was kind of a cool thing. And we had a guy here in the Halifax Center who was interested in all this sort of thing, and he looked into these old legends, and this was very significant to him that it ran along the equator. And at about the same time, just as an aside, stars, well, it'll come up, but stars like the Southern Cross and Alpha Beta Centauri were in fact visible from Greece and other temperate latitudes, even Canada, even southern Canada. At that time, you could see the Southern Cross and Alpha and Beta Centaurus. Now, the main star in Hydra is Alphard, which is Alpha Hydrae. And it's called the solitary one for kind of an obvious reason that it is the brightest star in Hydra, and it occupies a place in the sky which is almost devoid of anything nearly as bright. And so it's kind of on its own in the middle of nothingness, apparent nothingness. Alphard. I think you could probably pick this out in the city, but the other ones would probably not show up very well. So that's considered to be the heart of the snake, Alphard. It's a magnitude 2. So yeah, you should see that from the city. A variable double star. It's an orange giant. It's a K3 orange giant. And when we say giant stars are not on the main sequence of stars that are burning hydrogen like the sun. They tend to be much bigger than main sequence, the sun. They tend to be much bigger. They tend to be much more luminous and so on. The sun is actually considered a dwarf star, believe it or not. There doesn't seem to be any ordinary size stars, just giants, supergiants, and dwarfs. So now, of course, because it's a solitary star, tech magnitude, so it's no surprise it's also a classic navigation star and an alignment star. Now we're going to move to Boötes, the herdsman. I hope you've all heard this one, but to find Boötes, and certainly Arcturus, which is the main star, you go back to the Big Dipper and you follow the curve of the handle of the Big Dipper. There's a few stars there. So the phrase goes arc to Arcturus. You follow the arc of the handle of the Big Dipper and it leads you to Arcturus. So Boötes could be a herdsman, it could be a hunter, depending on what legends you listen to. Some indigenous cultures see that as a hero, or I guess here Stellarium thinks he's a hunter because he's got a spear, but I think more commonly is considered herdsman.
Yeah.
but he's got a sickle in his hand. So maybe he sort of double times. Maybe he moonlights as a hunter and he's mostly a herdsman. I don't know. But so Arcturus is the main star. There's a lot of interesting stars in Boötes, but we can only talk about a few of them. Arcturus Alpha Bootis, and it's called the Bear Watcher because it's always following the bear. What's that hanging out below Arcturus? Is that what I think it is, or is it just part of his tunic? I'm sorry.
I don't know.
I just saw that. I can't unsee.
Maybe I have the adult rating on.
Yeah. Anyhow, so we found Arcturus. Thank goodness we can't see the stellarium cartoons in the sky. So it is a magnitude 0. So you look for like, what is 0 magnitude? Arcturus is your magnitude 0. It's variable, like a lot of stars are variable, and it's the brightest star in the northern celestial hemisphere. So all of the stars that are brighter than Arcturus are below the equator. Sirius, Alpha Centauri, Canopus. I think it's 4th brightest in the night sky. In the summertime, when you're out waiting for it to get dark, it's always one of the first ones to appear, along with Vega. Some people see Vega first, which is almost as bright. Some people see Arcturus. Anyway, it's a good sign that the darkness is coming along. So it is, again, it's visibly orange, I find. I'm not very color sensitive, but when I see it, I see orange. And of course, the color receptors of the eye are always enhanced by using aperture. So when you look at things in a telescope, you would see the colors more in a more saturated way, I guess. And its name, it comes from the Greek for bear, Arctos. That's why it's Arcturus. It's a Latinized version of bear watcher, Arctos. Also, the same word gives rise to the Arctic and the Antarctic, as the bears are always associated with the north, it seems. So in Mi'kmaq lore, this is the departure. I'm going to say this because we teach this down here. The stories Muin and the 7 bird hunters, Muin being the bear, which is the bowl of the dipper. Arcturus is one of the 7 bird hunters in that night sky story, and it represents the barred owl, Gukugwes. Okay. So I wanted to point that out because it's an obvious one, easy to see, and it gives you, if you're looking for indigenous connections, that's an easy one to see and to remember. Now we're going to go farther along to Virgo. I think I said that right. Yeah.
Dave, before we move from Arcturus, just want to point out something on my diagram or my screen here.
Yeah.
Have the Arcturus just in the top of the screen, and then you can see this looks like 2, 4, 6 stars.
Yeah.
That forms Napoleon's hat.
Asterism. Oh, okay.
Speaking
I didn't
of asterisms there, yeah. It's just sort of right below or just to the south of Arcturus.
Yeah, that's
cool.
Yeah,
you can find this sort of pattern. Anyway, sorry to interrupt.
Visible in binoculars, I guess?
Visible in binoculars, like good pair of 8 or 10 power binoculars might see it, but mostly like small telescopes, and you can get it in the same field with Arcturus.
It has to be wide field though, eh?
Yeah.
Your view has to be wide field to no, I didn't. I wonder if that's in the RESC book of ever expanding book of asterisms worldwide, the Napoleon's hat. So we're going to move on to Virgo. And by the way, I've been trying to get the pronunciation of these constellations and star names correct ever since I was dressed down one of the previous episodes for not saying something right. Been trying to do it right. I look them all up in the Observer's Handbook. So Virgo, the maiden, and that's a zodiac constellation. By the way, I should point out that Leo, of course, because it's on the ecliptic, Leo is also a zodiac constellation. So today we're going to be looking at Leo, Virgo, and Libra, which are 3 in a row, which almost defines a season right there. So Virgo is a zodiacal constellation, the maiden, and she's associated with agriculture, and Spica, which is the Alpha Virginis, is represents the ear of wheat. I think in the picture there, she's holding an ear of wheat in her left hand, Spica. And to find Spica, we art to Arcturus, and then you spike to Spica. But people say spike to Spica, but it's Spica. But you continue on that route from Arcturus to find Spica. And it is a rotating variable double star, magnitude 1, and it's a dual star. There's a couple of B1, B2 stars in a really tight orbit that circles every 4 days. So I don't think you can see those. They're probably way too close, but that's probably what you call a spectroscopic binary. You can look at the spectra and see that there's rotating stars. There's red shifts and blue shifts and so on. And when I say it's a rotating variable double star, well, all stars rotate for sure. But when I call it a rotating variable, is the variability comes from the fact that these two stars are rotating around one another. They're probably not exactly the same luminosity. And they probably eclipse one another. And so you'll get this oscillation in the brightness of the star. Again, it's a classic navigation star and sky alignment star, a very useful one to know in the spring sky. Virgo is actually a very big constellation, but many of the stars are quite dim. So again, in the city, you might only pick out Spica. There's another star, Vindemiatrix, that might come up later. I didn't know that star. That's a star I should know, but I didn't. But it came up yesterday. Again, it's close to the ecliptic, and it also has frequent lunar occultations and nearby conjunctions, maybe not to the same degree as Regulus, but it's also one that is known to have close conjunctions with planets. So, and the other couple are Aldebaran and Antares. So there's 4 stars in the U.S. Navy's software. When you're calculating conjunctions, there's 4 stars they throw in there so that you can predict conjunctions with planets. There's Regulus, Spica, Antares, and Aldebaran, okay? Because they're very close to the ecliptic. Now we're going to go on to a very obscure constellation down below called Corvus. It's between Virgo and Hydra and next to Crater. And Crater is I would say, even a more obscure constellation. To see these constellations, you really need the dark sky. I have to say, they're not very prominent. Corvus is the crow, and I did a little research on this. It's one of the 9 celestial birds in the IAU constellation list. And the reason I did that research is because the Nova East Star Party this year, we decided we're going to have the theme stars and birds, because many of our amateur astronomer friends in the RASC are also bird watchers. I had the idea and I volunteered. I said, I will give a secondary talk maybe on the Friday night. And I was going to give a talk on the celestial bird constellations. And that's when I figured out there were 9. Only 3 of them are visible from the northern hemisphere. And those are Cygnus, Aquila, and Corvus. So that's how I got to that. The star I picked out of Corvus to talk about is called Gina. It's actually, I think it's the brightest star, but it's another case where for some reason it's not Alpha. I wish somebody would make up their mind about that, but it's Gamma Corvi, but its name is Gina Corvi, its actual proper name. And the reason it's called Gina Corvi is because there are other stars in the sky with the word Gina in them. And so it's called Gina Corvi to distinguish that one from the other ones. And in particular, there's a star just named Gina, which is in Epsilon Cygni, which is another bird constellation, because the word means the wing. Gina Corvi means the wing of the crow, literally. And so obviously Cygni's got a Gina as well, because there's wings, and I'm willing to bet, I haven't checked it out, I'm willing to bet that there's an Agena and Aquila and some of these other bird constellations. I'll find out when I do the research. So it's not so bright. It's a magnitude 2.6, also slightly variable. It's a double star. Another blue-white giant, B8 spectrum class. Again, it's a classic navigation star and an alignment star. So there might be better choices than Gina if you're in the city. You should be able to see it, but it's also fairly low in the sky because it's getting south, right? So anyhow, Gina Corvi, that's a star you should know. Now we're gonna have some more fun, and we're gonna go over to Libra. As you will see, at one time Libra, the stars in Libra anyway, were considered to be the claws, which belong to the Scorpion. And I haven't quite figured this out. This may date back to a point in time, believe it or not, before there was such a thing as astrology. And before the sky was divided up into 12 houses. Because if the stars in Libra were part of the Scorpion, then they wouldn't have been their own constellation. But I think it was the Romans or somewhere around then, it got carved off to be its own constellation. And to find Libra, well, you keep on going from Virgo down the ecliptic towards Antares and the Scorpion, and you'll find Libra. Stars, again, are not super bright. But the interesting thing is it's now depicted as a set of scales, but the stars have names associated with claws. So this Zubin Ganubi, try to say that 3 times fast. Zubin Ganubi is Alpha Librae. And it's only one of 3 stars in Libra that have that start with Zubin, which means claw. So Zubin Ganubi is the southern claw of the Scorpion, and its alter ego is Zubin Shemali, which is the northern claw. But we're just going to talk about Zubin Ganubi. It's the Alpha Libra. It's magnitude 2.8. It's a multiple star system, and the primary is a white A3 star. Again, it's a navigation star. And I've already mentioned that the nearby stars are also called Zubin. So there's a lot of lore there that might be worth looking into. I don't know. I'm seeing Zubin Ganubi 1 and 2 in Stellarium. I'm not aware of there being a 1 and 2.
Yeah, Dave, I'm looking at the Rask double star list, and it's listed there. It says to use binoculars, extremely wide, white, bright, pale orange. Separation from AB is 231 arc seconds.
Okay.
And there's a third one, and the separation from AC is 275 arc seconds.
So those are pretty wide.
Yeah, very wide.
Well, I don't know why it didn't come up as a double star. I might have missed that in my research. I'm going to have to check that out. I assume that if they're saying AB, AC, they must be physically associated.
The AB is physical. The AC is uncertain.
Okay. So I guess I'm going to go out on a limb and say if they're so wide, then it must be a fairly close star. But I didn't look that up.
Yeah,
what the distance is. Yeah. Say like whenever you pick at one of these stars, you find all these interesting things that you could follow up. And
yeah, for sure.
And I'd be there I'd be like spending a whole week preparing for this if I went down all of those. Anyhow, a cool star with a cool name. And the other thing about Libra is that, again, at the time of the pharaohs, why did they make this a balance? And I feel like at some point in history, the autumnal equinox, like the ecliptic, definitely goes through here. But where the celestial equator crosses is the autumnal equinox. And I think in ancient times, that autumnal equinox was in Libra. And so when the sun was at that point in the sky, there would be a balance between day and night. Now, that's not definitive. That's just something I came across. It might have been something that somebody made up, but it is true that in ancient times, the autumnal equinox was in Libra. So not as important as the vernal equinox, but still nonetheless. We're getting to the less known stars here, and I want to go to Centaurus. And you say, why are we going to Centaurus? Centaurus is a southern constellation, and it is, but I'm including it. Centaurus is the centaur, and it's normally considered a constellation of the southern hemisphere. But it turns out that the northernmost stars of this very large constellation are actually visible from Canada. So I guess we're seeing the top part of the Centaurus, which is the human part. So Mencken, I have a particular affinity for the star because when I was observing, I think it was only just last year, we had a really nice night in Ketchum-Kujuk, and I was like scanning around in the middle of the summer, and I saw this fairly bright star above the tree. And I said to Judy Black, what's that? What's that star over there? She said, I don't know. I said, it's pretty bright. We should know what it is, right? Stars you should know. And so I looked it up, and it turned out it was Mencken, which is Theta Centauri. And I got very excited. Doesn't take much, I guess. It means the shoulder of Centaurus. I just never realized you could see any part of Centaurus from Canada. And I just got really excited. And I thought, hey, that's really cool. I can remember that star. And it is a navigation star. Not very useful, I would think, that close to the horizon, because it's only above the horizon for a short while. I caught it just at the right time when it was culminating. It was just an accident, because a few hours before or after it would have been gone. And it's a magnitude 2.1 double star in Centaurus, and it's another orange K0 giant star. And Celestron uses it for sky alignment, not SynScan, but it is another classic navigation star. So I put on that on my personal list of stars you should know. And now we're going to head over to Corona Borealis. We're on the home stretch. If you go up to Corona Borealis, which is in between Boötes and Hercules, it's a nice little constellation. Most of us are familiar with it. It's the Northern Crown, for obvious reasons. It looks like a tiara. And it's Corona Borealis because there's a Corona Australis as well. And again, to bring in some First Nation sky lore, this is, if to the Mi'kmaq, this is known as the den of the bear. So it's kind of upside down, but you can imagine that as a bear's den, where Muin sleeps off the wintertime. And there's a couple of stars I want to talk about in Corona Borealis. Alphecca, which is Alpha Corona Borealis. It has Alphecca means the broken one. And I'm not sure why. I think maybe because the ring of the crown is not complete. And so I don't know, somehow Alphecca was applied to this star because it's an incomplete crown. It has another name, a completely different name, Gemma, which means the jewel. Gemma, well, I guess that stands to reason. And to me, that almost makes more sense. It's like the brightest star in the crown. So yeah, the jewel. And it's an eclipsing variable star. It has a 17.4 day period. So another well-known eclipsing variable star is Algol, which is only 2.7 days or something. But this is a longer one, magnitude 2.2. I don't know what the magnitude of the eclipse is, but if you're interested in variable stars, this might be one worth looking at because it's easy to find, have a fairly decent brightness, and maybe you could watch that. And it's a white A0 star. Again, a classic navigation star, and Celestron uses it. Now here's the star I really was going for in Corona Borealis. Its formal name is Variabilis Coronae, and it's a variable star. And so then the name literally means the variable star, or a variable star in Corona. So it actually has this formal name, Variabilis Coronae, and it's R Coronae Borealis, R being a common designation of variable stars. So I have a personal connection with this star because It's a variable. It's a very irregular variable star. It typically magnitude 5.9, and it irregularly fades to magnitude 14. In effect, it disappears. It's a yellow G0 supergiant. And when I first started doing observing with binoculars, it was in one of the binocular books I have. I became aware of this when I started observing with binoculars, because when I came back to astronomy after a 10-year absence, I didn't have a telescope, and I just got a pair of binoculars and started seeing what I could find. And I found out about this R Corona Borealis star, and that it irregularly faded. And so I started keeping an eye on it. And don't you know it, like within a couple of months of me starting to observing, I saw it dim. And this happens very irregularly. So I was very lucky to see that. And it was so cool, because it really was my first experience with any kind of variable star. And the fact that this star just disappeared, over a matter of days, it was just very fascinating to me. And so now when I go outside and I see Corona Borealis, I always just have a look to see if our Corona Borealis is still there. And it's easy to find, because it's like, if you go from left to right, there in the arc, there's, star 2 and star 3 in the crown. And it sort of makes a little isosceles triangle, almost equilateral triangle with those two stars. So I know exactly where to look for it. And most of the time I look for it, it's there, because it's mostly there. It only fades irregularly and then comes back. So that's something that's cool to do. If you're out observing, just keep an eye on our Corona Borealis and see if you can catch it. And it's unpredictable. Okay, let's go over to Ursa Major. Now we were at Ursa Major for the wintertime stars, or the northern stars, last time, but we were looking most. So now we're going to be looking at the southernmost stars in Ursa Major. So these are there's 3 pairs of stars at the ends of the legs of the Ursa Major, and the ones at the left there, Alula Borealis, which is the northern one, and Alula Australis. And I was like, right away when I found this, I said, you know what? Those are such cool names. We have to check those out. So this got nothing to do with the bear, but you can see there on the Ursa Major, there's 3 pairs of twin stars as you go from left to right. There's a pair there. There's a pair that we were just looking at, and the pair further to the right. And this comes from the Arabic. The Arabs called these the leaps of the gazelle. So they didn't see a bear there. This collection of stars were a gazelle leaping across the sky, and Alula is the first leap of the gazelle, and then the next set are Tania, and then the third set doesn't have a common name. There's only one of them named, but Alula Australis is Chi Ursa Majoris, and like I say, it's the first leap of the gazelle. It is the southernmost one. Alula Australis, it was the first star to be ascertained to be double, and also the first double star whose orbit was calculated. So that's its historical significance. And it is a slightly variable multiple star system, for a bright star, fairly dim, magnitude 3.8, a bit of a stretch in the city, but with binoculars, you should be able to pick it out. It's an F 8.5 yellow star. And as we just said, 1.5 degrees away is Alula Borealis. So you should be able to pick those out nicely in binoculars and think about them. And then if you feel like it, you could go and look at the other leaps of the gazelle if you have a good star chart handy. I got to get this right, Shane. Canis Venatici, right? Close.
Venatici.
Venatici? Oh, it's
Venatici.
Chichi. This is
Chichi.
it's Italian. It's not Latin.
Yeah, that's what we were told. It's like the Italian. Yeah.
The Italian Venatici.
Yeah.
Okay, so Canis Venatici is the hunting dogs, I believe, of the herdsmen, and it's found between the Big Dipper. There's this kind of somewhat empty part of the sky, and in that empty part of the sky, you will find Porcaroli, Alpha Canum Venatisorum. That's a mouthful. Charles's heart is the heart of King Charles I'm guessing, well, obviously the second, not the third. He just got, which was pretty cool. I was putting this together yesterday and I was thinking, it's or just the other day, I was like, well, it's King Charles III coronation coming up. And then we're going to talk about the Cor Corolli, Charles's heart. So it's a double star, magnitude 2.9, yellow, white, F0 star. And it was named in honor of King Charles II. Didn't he come after Oliver Cromwell deposed the previous king and he took over? He was like the first king brought back to the throne.
I think so.
Yeah.
We have many UK listeners. We will be corrected.
Yeah, we'll be corrected if we don't. Anyway, that's what I recall, Charles II. And I think there was a move afoot, and I'm not sure about this. There might have been a move afoot to make this a separate constellation or somehow break it out of, but that didn't work. But the name stuck. Cor Corolli. Now, Denebula, Arcturus, and Spica, Arcturus, Denebula, and Spica are sometimes called the spring triangle. And they're very close to being an equilateral triangle. I did the measurements. Two of the depth separations are 35 and one's 32. So it's very close to being an equilateral triangle. I don't know if they have asterisms on stellarium or not. So some people call that the spring triangle. But if you throw in Cor Corolli, which is at the top there, if you throw that in, and it becomes the spring diamond. Okay, so Cor Corolli, Arcturus, Spica, and Denebula, and back again. It's a diamond, and those are sort of the brightest stars in the sky. Now, look at that star that's at the top of Virgo. Go back and click on that. The logo for the 2023 RASC General Assembly is the spring triangle, the stars of the spring triangle, with Vinda Meatrix stuck in, and they've got them all connected with lines. So if you go to the RASC General Assembly logo, that's where it comes from. They've got the spring triangle, and then each star is connected back to Vinda Meatrix, and that's where the logo comes from. Those are the spring stars you should know.
Well, thank you so much. Is it James Muirden? Binocular astronomy?
Yeah, that's the guy. I knew it was an M. James Muirden. The stars just seem to speak for themselves. They all have interesting stories. So I have great confidence that we're going to be able to end up this series and have more fun looking at stars you should know.
Shane, do you have anything to add before we conclude?
Yeah, just to kind of echo that, Dave, I don't think you need to do anything to spice it up. I think the content itself kind of takes care of that. It's quite interesting to dive into some of these stars' details. I think you kind of mentioned this at the very start of this series about how we sometimes overlook the stars in the sky in favor of chasing down galaxies and nebulas and other things. So I really enjoy just changing the topic a little bit and focusing in on stars. Yeah.
That's great. Well, I know I've worked with a few beginning amateur astronomers who observers, and the ones that I've worked with and coached, they like to start by learning the sky, which is always a good way to start. Just learning the sky. Some people anyway take a lot of interest in the lore and the names, and in some cases know them better than I do. But it's something that's always fascinated me. So it's kind of like in between, like learning the constellations and then going to the deep sky stuff. In between are the stars, and yeah, I'm just trying to bring back a little more interest in the stars themselves.
Well, that's great. Well, thanks so much for joining us today. Personally, I would like to see how spicy you can make things, but that's just me.
Well, you got us, you got us going down that track there. Well, it was a pleasure, always a pleasure.
It's always a lot of fun. And thanks to the listeners for listening. Please subscribe and do us the favor of sharing the show with other stargazers you know. And you can always reach us at actualastronomy@gmail.com.
Thank you everyone for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.